Let ABCDEF be a regular hexagon. And as a regular hexagon, let's just draw it. Square APQR is constructed inside a hexagon such that points P and R lie on the perimeter of the hexagon, and point Q lies on segment AD. So we know that point Q will lie somewhere here. And we know that point P will just lie somewhere like this. Point P and R will lie somewhere like this. P and R. Given that DQ is square root of 3, the side length of the hexagon is m plus root n, where m and n are positive integers. Compute m plus n. So we kind of drew our diagram here, but first we should probably find the length of AD first in terms of S, where S is the side length of the hexagon. See that if each side length is S here, then if we drop down some altitudes, we see that we form two 30, 60, 90 triangles. 60, 30, here's a right angle, and here's 60 and 30 as well. We see that by 30, 60, 90 triangle ratios, this is S root 3 over 2, this is S over 2, and similarly, this is S root 2, S root 3 over 2. This is S if we drop down the side length of this side of the hexagon down to the parallel, the same other side of the trapezoid, we get this length to be 2S. So AQ here, we do think of it analogously, we get 2S minus root 3. That's our diagonal of the square. And so by 45, 45, 90 triangle properties, we get all the side lengths of the square is going to be a 2S minus root 3 over root 2. We can proceed to do some angle chasing, and we see that this angle is 15 degrees. This angle is 120 degrees because it's a regular hexagon. And so this angle here is 45 degrees. And so here we know the length of AF. We know the angle opposite to AF. We know the angle 120 degrees, angle AFP, and we know the side length opposite of that angle. So we can use law of sines here. And so for the law of sines, we see that sine of 45 degrees over AF equals sine of 120 degrees over AP. And so we kind of solve, plug in those values and find S. We get AF is going to be S, and AP is going to be 2S minus root 3 over 2. Sine of 45 degrees is root 2 over 2. Sine of 120 degrees is root 3 over 2. So we get root 3 over 2S equals 2S minus root 3 over, root 2 here, times root 2 over 2. The root 2's cancel. Divided by 2, here we get S minus root 3 over 2. Moving the S's to the other side and the constant on the other side, we get root 3 over 2 equals S times 1 minus root 3 over 2, S times 2 minus root 3 over 2. We get S to be equal to root 3 over 2 minus root 3. We want it in the form m plus root n, so let's multiply by its conjugate. 2 minus root 3 times 2 plus root 3. We get 4 minus 3, which is 1. So we get 2 root 3 plus 3. And 2 root 3, you bring the 2 in. It's 2 squared by 3 inside the square root. You get 3 plus root 12. M equals 3, n equals 12. M plus n is 15.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.